Today's video is going to be on patterns. We're going to look at different patterns that we see, and we're going to use those patterns to write equations. We're going to start by writing the function rule, which is just another word for an equation. So we're going to write the function rule or the equation of the given data that we're going to find in a table. We've already talked about how to find the slope and to find the slope or the rate of change, because remember those two words mean the same thing. We need to find the change in y and the change in x. So from 6 to 3 we're going down 3, down 3, down 3, down 3. If we want to find our change, so our change in y is a -3. We're going to find our change in x. We're going up 1, up 1, up 1, up 1. So our change in y is going to be up 1. And your rate of change is going to be your change in y over your change in x. So your change in y is always going to go on top, the change in x is on the bottom, so your rate of change or your slope is going to be a -3. Now your starting point is another word for your y-intercept. And remember that your y-intercept is always 0, comma, whatever your number is. So we say 0b. So in this case, your y-intercept is at 0, 6. It's only the starting point, or only the y-intercept, is if that x value has a 0 there. So we're going to write our function rule or our equation in slope-intercept form. And just in case we forgot slope-intercept form, y equals mx plus b. So we've got y equals m, our slope, and our slope is -3. X plus our y-intercept, which is, oops, not b, but 6. So the equation of the line represented in the table is y equals a -3x plus 6. Now our next one. Start again with our change in y. So we're going up by 4, up 4, up 4, up 4. Now our change in x's, we're going up 1, up 1, up 1, up 1. So we've got our change in y of a +4, our change in x of a +1, which means our rate of change is 4 over 1, which is just 4. Now our starting point, remember we've got to look for zeros in the x column. No 0, no 0, no 0, no 0, no 0. So we actually don't have the 0 labeled there. That does not mean that there's not a 0 capable, it's just not shown. So what we want to do is we want to work backwards to find that 0. So each of these we're going up by 1. So if I want to work backwards, I would subtract 1 to get 0. Now for my y's, I'm going up by 4s each time. So if I want to work backwards, I would subtract 4 to find that my y-intercept is at 0, 2. Which leads me to our function rule. Y equals your slope of 4x plus your y-intercept or starting point at 2. Now you don't have to go through all of that, listing out all the information in order to write the equation. That's just to help you understand where it's actually coming from. So if I wanted to write the function rule from this, I would find my changes up 1, up 1, up 1. And our y's, I'm going up 4, up 4, up 4. Now, don't be tricked just because I turned the table and made it go sideways. It still has to be your change in y over your change in x, which means it's 4 over 1. And then when we look at our table, we need our y-intercept. Our y-intercept is when your x value is equal to 0. So taking our slope, we've got y equals 4x, our y-intercept, at a -3. I don't think that maybe you couldn't look at the table and go directly from here, but you don't necessarily have to write all that information down. Moving on. Take this one, and I want you to press pause, and I want to see if you can get the function rule all on your own. Alright, press pause, don't cheat. Alright, so hopefully you got that the slope was 1 by taking your change in y and divide by your change in x, And then, hopefully you did not get tricked. This is not your starting point because you want the x to be 0, not the y to be 0. So you actually had to work backwards in your table, so subtracting 1 to find when x is 0, subtracting 1 to find that your y, or your y-intercept, is a negative 3. So your function rule is y equals x minus 3. Now we're going to switch gears and put things in perspective that you've probably never looked at before. So we're going to be able to write an equation from a given pattern in a picture. So the first one is representing the number of apples on a tree. On day 1, you have 3 apples. The red dots are supposed to be apples. On day 2, we have 4 apples. On day 3, we have 1, 2, 3, 4, 5 apples. I wonder what's happening here. I think each day I'm adding another apple. So if I wanted to go to day 4, I'd have 1, 2, 3, 4, 5. I would have 6. 1, 2, 3, 4, 5, 6. And if I wanted to go to day 5, I would have 7. 1, 2, 3, 4, 5, 6, 7. Alright, so we're adding 1 apple every single day. We start off with 3, 4, 5, we go to 6, and 7. So when we want to write the function rule, we have to think about what slope is and what starting point is. Slope is the rate of change. Remember, those two words mean the same thing. And what I'm doing is I have a rate of change of 1 apple each day. And that is going to be my slope, or my rate of change. Your starting point is, remember, it's always when it is at 0. So when I look at this, I start at day 1. I need to start at day 0. Now, one issue we're going to have, and don't freak out about it, is that sometimes day 0 isn't realistic. It may not exist. It's only there for the function rule purposes. But you know that if you get a negative number of apples, that's not part of the real world. But it has to be there for the equation. So if I were to work backwards, on day 0 I would have 2 apples, and that would be our starting point. So when we look at our equation, the number of apples that we found is that we get 1 apple for every day there is, and we started with 2. So our equation would be y equals 1x plus 2. That equation would model our apples on a tree situation. Alright, our next one. Each figure is made up of toothpicks. Draw the 4th figure and determine how many toothpicks make up each figure. So what I want you to do, again, is I want you to press pause. I want you to kind of inspect the 1 triangle, the 2 triangle, and the 3 triangle, and see if you can tell me how many toothpicks are in each of them, and then draw the 4th triangle. Alright, so when I counted the number of toothpicks in 2 triangles, I got 10 toothpicks. When I counted the number of toothpicks in 3 triangles, I got 14. And then I drew my 4 triangle figure, and I got 18 toothpicks. So predict the amount of toothpicks it would take to create 10 triangle pattern. Either choose a concrete representation, and the concrete representation is drawing more triangles, or develop a function rule. So I don't know about you, but I don't think I'd really want to draw a concrete representation. That means I'd have to draw out 10 triangles. And it was enough work for me, at least, to draw out 4 triangles. So what I want to do is develop a function rule. So again, your rate of change is how much you're changing by each time. So if I go from 1 triangle to 2 triangle, I'm adding 4 toothpicks. If I go from 2 triangles to 3, I'm adding 4 toothpicks. From 3 triangles to 4, I'm adding 4 toothpicks. So what that tells me is that my slope is 4 toothpicks for every single triangle I'm adding. Now hopefully you remember that our starting point is not going to be 6. Our starting point is when we are at 0, not at 1. So if I were at 0 triangles, and remember that's not possible, you can't have a 0 triangle figure, but you need it for your starting point. Instead of going up by 4, I would move 4 back, which means I would have started with 2 toothpicks, and obviously with 2 toothpicks, you don't have any triangles. So we take our slope, y equals 4x, and our starting point at a positive 2. This would be our equation we would use to find it for any number of triangles. If I wanted to have a diagram for 100 triangles, this is what I would use. And again, we wouldn't want to draw out a 100 triangle diagram, so we would use our function rule. And since we want to find 10 triangles, we plug in 10 for x, because y is representing the number of toothpicks, so this is going to be representing our x variable, the number of triangles, and the number of toothpicks is going to be representing our y variable. And that's because of our independent-dependent relationship. The number of toothpicks is going to depend on how many triangles you have. Therefore, the dependent variable is the y variable, the independent is the x variable. And that gives us that we're going to have 42 toothpicks. And again, remember, we have a word problem. We have something that we're talking about, so you must label your answer with toothpicks. You can't just tell me that it's 42. Alright, so use the table to determine if your prediction was correct. So we said that 2 triangles was going to give us 10, 3 gave us 14, 4 gave us 18. So we're nowhere that we're adding 4 toothpicks every time. So plus 4 would give us 22, plus 4 would give us 26. That would give us 30, 34, 38, 42. So even doing it a long way of just adding 4 each time, we still see that we were correct from our function rule that we were going to need 42 toothpicks. Alright, so to recap, when you're doing a function rule from a diagram, what you need to do is 2 things. 1, find your slope or rate of change. How much is your diagram changing by each time? That's going to be the number with your variable. It doesn't have to be x. Any variable that you want to use. And then your y-intercept, or your starting point, is how many do you have at 0. And you can't forget that most of your diagrams are going to start at 1, not at 0. So you're going to have to work your way backwards to find the 0 for your y-intercept, or your starting point. And that will be all for today. You're all done.